Okay, now let's continue with logarithmic function. For the logarithmic function, basically the shape looks like exponential function, if you can see. Okay, but now it is vertical graph. Just now we made the exponential function horizontally, but for the logarithmic function it is vertically. So if it is vertically, it passes through the x-axis. It passes through the x-axis. Therefore, we need to find the x-intercept. X-intercept. So in order to get the x-intercept, we need to substitute the y value with 0. Or we can say that your fx now is 0, then we can find the x-intercept. Okay, and basically for the logarithmic function, the graph will be vertical increasing or vertical decreasing. Vertical increasing when the base number here is more than 1. Vertical decreasing when the base number here is more than 0, less than 1. Okay, so let's look at the example. Example 6.31. We need to find the inverse first for the fx equals to a to the power of x. Okay, if you and this a is for more than 1. Okay, in order to get the inverse for fx, normally we let the function become y. Okay, and then we try to use the log. Or we try to write this equation in the form of log. So if you write in the form of log, it will be x equals to log base a y. If you can still remember this rules of log or rules of index, it will be easier for you. Okay, it's just that from the index we can transfer or we can convert to log, just by taking the index as the subject, and then we write the log and we take the base, the same base here, and then the y will be the number. Okay, so we have gotten the x as the subject in terms of y. So this is what we want. We want to have the inverse function. So we call this as the inverse function of x. Okay, so if this x, that means your what we call this unknown also should be x. So basically we change this x become f inverse x, and this y will be changed to x. Okay, this is how we do for the inverse function. Okay, let's recap the inverse function. We can get from, we let the function become y, and then we try to get the x as the subject in terms of y first, and then later we write the x as the inverse function and y we change to x. So here we should have in terms of x, that's why whatever we have here should be changed to x also. Okay, this is the inverse for the function here. Okay, so if you can see, the logarithmic function is actually the inverse for exponential function. Logarithmic function is the inverse function for exponential function. Okay, so basically if you want to sketch the graph, it must be reflection to each other. This graph should be reflection of this graph. This graph is the reflection to this graph on the line y equals to x line. Okay, so let's say the question asks you to sketch the graph of the function. So you can choose either you want to sketch the graph of fx first, or you can either sketch the f inverse first. So up to you. And then the other one will be the reflection to the other graph. Okay, so let's say I want to sketch this one first, because I know that the graph of exponential will be horizontal curve, and it will pass us through the y-axis. Okay, so in order to sketch the graph of the exponential, basically we need to have the y-intercept. So for fx equals to a to the power of x, the y-intercept here we can get from when x equals to 0. So when x equals to 0, a0 equals to 1. So basically the graph will be like this. We sketch the y and x axis first. These are compulsory to write. And then the 0. And then let's say the 1 is here. This is what we call as the y-intercept. And we know that this graph has no other terms for the exponential function. Therefore, the asymptote or the horizontal asymptote is at y equals to 0. So make sure when you sketch a graph, no graph or no point can be touch the x-axis, because the x-axis now is the asymptote to this graph. Okay, so basically it will be like this. Okay, how do I know either it is increasing? Because this one, the a value, I already stated here that a is more than 1. So basically it will be increasing, and other than that, the x here is positive. It is not negative x, it is positive x. Therefore, the graph should be increasing as well. Okay, and then to sketch the inverse function of ax, we just need to sketch the dotted line, which is this line is actually y equal to x, so 45 degree, or divide the xy axis, the x and y axis symmetrically. Okay, so this function or this graph will be the reflection of this graph at y equals to x line. So we know that if this is 1, another part here also will be 1, because it is a reflection. So it must be the same thing. But this value is for y value, while this value is for the x value. So in other words, you don't have to find the x-intercept anymore, because we know that they are reflection. So this one you don't have to find, but we just need to plot by taking the value here. Okay, will be the same value. And then since they are reflection, so we just sketch the reflection and make sure this graph also cannot touch the y-axis. Remember, the first graph here does not touch the x-axis, because we know that the x-axis is the asymptote for this function. Therefore, for the inverse function, it will be vice versa. That means the y-axis here will be the asymptote for this graph or for this function. So do not touch the y-axis. We just sketch the reflection like this, something like that. I think you can sketch better than me. It has to be similar or same distance between here and here. It has to be same distance, and here also the same distance. So it has to be go to the right a little bit, and same goes to here. Must be the same distance. Okay, so if you can see, they are actually the reflection of each other. So basically, the logarithmic function is the inverse for exponential function. Okay, for the example 6.32, we can go through here. The function f and g are defined by fx equals to ln 3x minus 2 for x more than 2 over 3. Of course, x more than 2 over 3, because the 3x minus 2 cannot be 0 or less than 0, because this is a logarithmic function. Remember, when you test the value using your calculator, ln or log 0 or log negative or ln negative will be undefined. That's why the number here should be more than 2 over 3, not include 0. This one cannot be equal to 0 as well. So it must be more than only, no equal sign. Okay, and you can see here, this is what we call as exponential function, because we have exponent and the x is in the index. Okay, please, I think you can ignore the denominator, because there is no, not ignore, just ignore for a while, because we cannot see this one as the rational function, because there is no x in the denominator. So this is not the rational function. The rational function is when the x is in denominator. Okay, but now our x is in numerator only. So first of all, we need to show that fx is a one-to-one function. So there are two ways in showing the fx is one-to-one function. Either you use the algebraic method, or you also may sketch the graph and just reuse the horizontal line test. But for this case, I prefer you all to use the algebraic method, because later you need to sketch the graph. So you don't have to do the you don't have to do the work twice. Okay, you don't have to sketch the graph twice. Okay, so show that fx is one-to-one function. So as I mentioned previously, the first two steps are compulsory for you to write. That means you let the x1, x2 becomes the element in the same domain of the function, and then you assume that if you substitute the x1 and x2 into the function, they should be similar until you get x1 equals to x2. This means your function is one-to-one function. Okay, and then B, hence show that fx and gx are inverse to each other. So in order to show, this one you must show that you have to use the composite function. Okay, this one I think you can refer to the note in page 195. Yes, I'll show you. Okay, this is the note. Okay, if f and g are a one-to-one function satisfying, f gx should be equal to x and g fx should be equal to x. That means if you want to show that is the inverse function is that they have the inverse function, you must show that the composite function should be equals to x. At the same time, the composite function of the other function is equals to x, just like we did in matrix. If you still can remember, if we have A, B equals to identity, therefore we can say that B is the A inverse. Okay, so same goes to BA. If we have two matrices, multiply each other and we got identity, automatically we can say that A is actually the B inverse. So same like here, if we have f g x, we got x, and we can see that the gx is actually the inverse of f. Gx is the inverse of x. F. Same goes to gfx. If we got x, that means we can say that fx is actually the g inverse. So in other words, the x here is the identity function. Okay, we call here x is the identity function. So whenever you see the question says identity function, automatically you need to refer to the composite function, and then you need to get the x. Okay, composite of two functions, you will get x. X is the identity function. Okay, so you can refer to 195, page 195. Alright, so when here, to show that fx and gx are inverse to each other, so make sure you use the composite function and you should get x. So let's try. If you use fgx, can you get x? Okay, when you substitute the gx into f, it will be like this, and then you try to simplify. Okay, and we can see that ln e is equals to 1, that's why we got x. So obviously when you got x, that means the gx is the inverse of f, while the f also the inverse of gx. Okay, done with that. C, state the range of fx and gx. So by looking at this, automatically we can see that the x more than 2/3 is the domain for fx, while the gx will be real number, because this one is we refer to exponential function. So basically you can imagine the exponential function graph will be like this, like this. Okay, But if I do like this, you don't see, so I need to do like this. Okay, it will be real also for the domain. Okay, and then C, state the range of fx and gx. So range. Just now we talked about the domain. Okay, the range. So if you can remember the logarithmic function, the graph will be like this, something like this, right? So the range obviously is real, from negative infinity to infinity. It doesn't stop. And then the graph for the what we call this exponential function will be like this. Okay, so we can see that the range of this one is 0 to infinity. Remember, it does not touch the 0, but it starts from 0 to infinity, exclude 0. And here, the range of f is real. Okay. And how to get the domain for the logarithmic function? Okay, as I mentioned just now, logarithmic function, it has condition which the number here, after the log, the number cannot be equals to 0 and the number cannot be less than 0. So automatically we need to tick this one, and we must to make sure that it is always more than 0, and then x should be always more than 2 over 3. So this will be the domain. Okay, this is how we find the domain for the logarithmic function. Okay, and then for sketch the graph, we have done for the range, right? Okay, sketch the graph of fx and gx on the same coordinate axis. So basically, we can see that they are inverse to each other because we have answered the second one. So that's why we can say that they are inverse to each other. So when they are inverse to each other, you can just sketch the reflection of the other one. Okay, so basically you can sketch the logarithmic function first, ln 2 over ln 3x minus 2 first, or you also can start by sketching the gx first, which is 2 plus ex over 3. So up to you. And the other one will be the other one will be the reflection to the other one. Allah. Okay. Alright, so you can see here, this is gx, this is exponential function graph, and then we sketch the dotted line, and then we have logarithmic function. Here, this is the reflection of each other. So simple, right? Okay, now we are in our last example for today. The example 6.34 here, I want you all to do it on your own first. You try it first, but I will give you the hint later. Okay, now we look at example 6.33 first. Oh my god. Okay. The function f and g are defined by fx equals to ln 3x minus 1, gx equals to 2 to the power of x. Okay, this is the type of the question will come out in your, most probably in your final exam. It looks like this. Okay, the type of question looks like this. Okay, the function f and g are defined by, okay, I write first the function fx equals to ln 3x minus 1, and then gx equals to 2 to the power of x. Determine the inverse function of f and state the domain and range of f inverse. Okay, so it's very simple to find the inverse. We let first the y become the function, and then we try to get the x as the subject in terms of y. So do whatever you can do. Let's say we don't want ln to be here, so we exponent of both sides, 3x minus 1, and then at 3x equals to, I will do it one by one so that you can see, x equals to ey plus 1 over 3. And since we want to have the inverse function of f, right? Okay, so this one we can see that x is f inverse, and this will become x. Okay, please check. Y equals to ln 3x minus 1, ey equals to 3x minus 1, 3x, ey plus 1, x equals to ey plus 1 over 3. Okay, done. Okay, now we need to find the domain and range of f inverse. So basically you need to imagine the graph of exponential function. Why did I say this is exponential function? Because we have x in the index and the denominator here is only a number, not including the variable. So we don't see this as a rational function, but we see this as an exponential function. Okay, so you may imagine that the graph of exponential will be like this. Basically it will be like this, right? So the domain of this is real. They want the domain and range of f inverse. So the domain of this graph is real and the range of f is similar to the domain of the original function. Remember, range of f inverse is domain of f. So if you can know what is the domain of f, you will know that the range of f is the range of f inverse is similar to the domain of f. So the function of f is logarithmic function, and basically for the logarithmic function the graph will be like this. Okay, so the domain here, the range here is also real. Oh, wait a minute. Domain of f inverse. Oh, wait a minute, sorry. The domain of Allah Akbar. Oh, sorry. This domain, it is ln 3x, right? Okay. Ln 3x, the domain is, as I mentioned just now, it must be 3x minus 1 more than 0, so x more than 1 over 3. So by referring to the domain of f here, the domain of f is 1 over 3 to infinity. So it will be 1 over 3 to infinity. Okay. And then the second question is, sketch the graph of f and f inverse on the same coordinate axis. So as mentioned just now, the graph of f and f inverse should be reflection of each other. Why? Because we have gotten the f inverse function, and this f inverse obviously is the inverse of f function, so they must be reflection of each other. So first you must sketch, or up to you whether you want to sketch the f inverse of f first. So basically if you want to sketch the f graph first, the domain will be from 1 over 3 to infinity. That means your what we call this, asymptote is 1 over 3. That means the graph will not touch the 1 over 3. Remember, when we do this, when we try to get the domain, this cannot be equal to 0, remember? So it has to be always positive number, not including 0. That's why we see this. Okay, and then this means x more than 1 over 3. So we set the graph from 1 over 3 but not include 1 over 3. And then if you want to find the x-intercept, up to you. X-intercept is to find the x-intercept is you substitute the x-intercept. Where is the x-intercept? Okay, you substitute the the y value with 0. This one, if you want to find the x-intercept, you have this function. Okay, so you can see that y equals to 0. That means this is 0 equals to ln 3x minus 1. And then this is equal exponent 0 equals to 3x minus 1. Exponent 0 is 1. Okay, 1 plus 1 is 0. So 3x equals to 0. 1 plus 1 is 2. So 2. X equals to 2 over 3. That means the the x-intercept here is 2 over 3. So your graph will passes through this point. Okay, and it does not touch this line, because this line is the asymptote for the graph of ln 3x minus 1. So the graph will be like this. Something like that. So when you sketch the graph for the inverse, the point or the asymptote for that graph or for the inverse graph will be 1 over 3. Y equals to 1 over 3. You sketch the dotted line, and then you sketch the y-intercept. Basically it will be similar value with x-intercept, because this is just a reflection. Okay, and then the graph will be reflection of this graph, so it will be something like this, something like that. So you can see that it has to be similar distance, okay, from left and right. This is y equals to x line. Okay, so this is how we do the graph of inverse function. Okay, the logarithmic graph and also the exponential graph. Okay, then C, find GOF and state the value of x for which GOF x equals to 4, giving your answer in terms of E. So this is simple because we can see that GOF is the composite function. You substitute the fx function into gx function. So basically the gx function is 2 to the power of x, while the fx function is ln 3x minus 1. I just write the two functions first so that it's easier for us to refer. GOF x means gfx. What does it mean? It means we substitute the function of fx into gx. So we have 2, and then the function, the x here need to be substituted by the fx function. So it will be ln 3x minus 1. Okay. And then what else we need to do? State the value of x for which GOF x equals to 4. So we need to compare with 4, because here stated GOF x equals to 4. That means this one is equals to 4. We take this, make it equals to 4. That means this is 2 ln 3x minus 1 equals to 4. And then you want to find the value of x. So please think how to get x values. So what can we do here is so in order to solve this one, we put ln at both sides. Ln 2 ln 3x minus 1 equals to ln 4. Okay, and then this ln can be this one can bring forward. Ln 3x minus 1 ln 2 equals to ln 4. Please remember the rules of ln also, and this 2 can be divided. Okay, ln 3x minus 1 equals to ln 4 over ln 2, while ln 4 over ln 2, if you can use here, ln 4 over ln 2, it is equals to 2. Okay, if you can see, so 3x minus 1, and then we don't want ln to be here, so we put the exponent, or we exponent both sides, and then x only is exponent 2 plus 1 over 3. Exponent 2 plus 1 over 3. Okay, so we want to find the value of x. So this is the value of x in terms of exponent. Okay, for this example, you can try it on your own first. The same concept. You need to determine the domain of f by taking this. Okay, I think I give you the solution for the first one, because I'm afraid if you are not very familiar to find the domain for the logarithmic function. So basically for the logarithmic function, the number here cannot be less than 0 or equals to 0. So it must be x plus 1 over x minus 2 more than 0. This is the first thing that you should find first, or the first thing you should state first. Okay, and then if you can see here, this is actually the rational inequality. So please relate with the rational inequality, how to solve the rational inequality. Okay, so this one, if it is rational inequality, you may use the real number line method. So we consider all the factors positive. So x more than -1. Same goes to the denominator. X minus 2 more than 0, so x more than 2. And then we make the real number line. We construct the real number line. So we have two numbers here, -1 and 2. And they both go to the right side. And this is negative, negative, positive, negative, positive, negative, positive, positive. Okay, and then we take the positive area since the inequality here is more than. So the answer here is x less than -1 or x more than 2. So meaning this will be the domain of this function. Okay. So the domain of f is, you can write in the form of set form, x less than -1 or x more than 2. Okay, done. B, show that fx is one-to-one function. So to show that fx is one-to-one function, I prefer you all to use the algebraic method because you don't have to sketch the graph yet. Later you need to sketch the graph. Oh, no need also. So you just find the using the algebraic method to show that the fx is one-to-one function. Obviously, the first two steps are the same thing. That means you need to let the elements become the domain of f. And then you assume that when you substitute the fx1 and the fx2 into the function, they should be similar. Okay, I'll show you. Wait a minute, I need to have extra page. Okay, so we are now in B. Show that fx is one-to-one function. This is our recap also for the chapter 6. Okay, so first of all, we let x1, x2 are the element of domain f. Domain f is this domain. And then we assume that if we substitute the first element into the function, it must be similar when you substitute the second element into the function. So we substitute as usual, ln. This will be x1 plus 1 over x1 minus 2, still x1 because they are in the same side, while this one will be x2. x2 plus 1 over x2 minus 2. And then both sides have ln, so you can cancel the ln. And then you compare the numbers. x1 plus 1 over x1 minus 2 equals to x2 plus 1 over x2 minus 2. So what else can we do here? We just do the cross product. x1 plus 1 times x2 minus 2 equals to x2 plus 1 times x1 minus 2. And then you expand x1, x2 minus 2x1 plus x2 minus 2 equals to x1, x2 minus 2, x2 plus x1 minus 2. Okay, and then if there are something can be cancelled, you just cancel here. And I think both have -2. Yes. And then we have -2x1 plus x2 equals to -2x2 plus x1. And then you try to simplify the equation. Negative x1 plus 2x1 will be 3x1, x2 plus 2x2 will be 3x2. And then you can cancel the number 3, and then you can see that x1 is equals to x2. This means the fx is one-to-one function. Alright. Okay, C, if gx equals to 1 plus aex over ex plus b is the inverse function of f, find the values of a and b. So what does it mean by inverse function of f? That means you must find the inverse function of f first, and then you compare with this one to get the e and b values. I think that one you can do it on your own first, and then show that FOG equals to I, where I is the identity function. So this is what I mentioned just now. I is the identity function. That means the identity function or the function that you need to get here is x. FOG is equals to x. That is the question 1. Okay, the question actually wants you to find the composite function equals to x. So please try to find by using the composite function and make sure the answer is x. Okay, I think that number C you can do it on your own also. I mean both questions in number C you can do it on your own first before we can discuss in our next class. Okay, with that we end chapter 6, Alhamdulillah. So I hope that you can study chapter 6 on your own. Until next video, thank you.